Hello, my name's Kevin Salvage from Leader Europe, and I'm the Sales Engineering and Technical Marketing Manager based in London in the UK. Thank you for joining us today, and we're going to go through how leader scopes are used on set to ensure that your production is delivered to the post-production house with the minimum fuss and inconvenience so that they can then do their creative work and deliver quality product to your end clients. With the growth of high-end feature film type programming for the new OTT streaming services like Netflix and Amazon, feature film production techniques are starting to be implemented by more and more productions. Although well funded, they do not receive the same level of funding that feature films enjoy. So although they use many of the same production techniques, they have to also make savings without compromising production values and the quality of the final product. One of the ways that productions have managed to walk this tightrope is by ensuring that the on-set technical monitoring of the production enables any mistakes to be corrected immediately on set without relying on it being fixed in post at additional cost. So why do we need a waveform monitor on set? Well, before you start recording, you must ensure that your camera is set up correctly. It may be that you're renting the camera and you need to check the settings prior to carrying out your production. It could also be the case that you've got multiple cameras and you need to ensure that they're all matching. So, ensuring they are all set up correctly is essential before you even start recording. Traditional film cameras are now being replaced by digital film cameras that record directly onto solid state removable media. To ensure that everything is being recorded correctly, some form of monitoring is required. Monitors can look different due to the amount of light reflection on the screen or how the monitor was calibrated. So this is why we need to have a waveform monitor on set to give us an accurate representation of the signals that are captured by the camera. In our previous video, we talked about how you white balance a camera and you ensure that the red, green and blue channels all have the same level so that white objects continue to appear white irrespective of the light source. The same setup also applies to the black levels. Video cameras possess a function called black balance, which calibrates the signal for no light. So, just as we have white balance function, which gives the reference to true white, we also have black balance, which correctly sets up the blacks. To ensure accurate reproduction from the camera, it is imperative that the camera reproduces a true black when the lens is closed. Otherwise, a colour cast, a tint of a particular colour may be seen. Like with the white balance, this requires accurate matching of the red, green and blue-black levels, and this can only be achieved by using a waveform monitor. Black balance will ensure that any hot pixels that are not visible on the camera viewfinder are corrected before shooting. Otherwise, they will have to be fixed in post, which will require additional time and increased post-production costs. Unlike white balance, black balance does not need to be adjusted every time. If you are frequently changing your shooting environment from hot climate to cold, or vice versa, camera sensors are sensitive to heat, so black balancing should be carried out. It's also recommended to black balance a camera if the camera has been subject to high altitudes, like on a flight, as the camera sensor will be subject to more cosmic rays at high altitudes. You should always adjust the white balance both before and after adjusting the black balance. It's also recommended if any gamma settings are changed on the camera. Always consult your lens and camera manufacturer's setup instructions to ensure that the lens and camera are correctly set up for calibrating the black balance. Ensure that the camera knee correction and white clip are switched off and gamma settings are correct, and the lens is set to the correct f-stop setting. If black is set to 0, Crushing cannot be picked up by a waveform monitor and can affect the tracking as well. If one colour is crushed at black, the chip does not turn on at the same time as the others to begin its journey to white, and this can have an impact on the images you're capturing. Therefore, it's recommended to set black at 1 or 2%, then balance the camera for black. Then it can be dialed down to 1 or even 0, but flare needs to be checked at this point as well. To ensure that the camera is correctly adjusted, productions will use a grayscale test pattern chart to ensure the setup of the camera. The grayscale test pattern chart contains both black and white tiles, as well as middle grey. The black area of the image should correspond to 0 on the IRE scale. When the black balance of the camera has been correctly set up, the black area of the image will continue to correspond to 0 on the IRE scale, even when opening the iris to 30% more than its original position. Once the black balance calibration has been completed, it's recommended to carry out a white balance once again. So that concludes how to set up the black balance on a camera using a LiDAR waveform monitor on set. If you found this interesting and would like to learn more, please subscribe to the LiDAR Europe YouTube channel, where you'll find lots more interesting videos about test and measurement and LiDAR products. To accompany this video, LiDAR have a white paper that details how LiDAR scopes are used in on-set production. To download a copy of the white paper, simply use the QR code displayed on the screen and register your details.